Dear students, in the lecture series of Computer Organization and Architecture KCS 302, I welcome back you all in the unit 5th, that is Input Output Devices. It is our lecture 1 of unit 5th. Let's start with lecture 1. The contents of this lecture 1 of unit 5th are peripheral devices, input output devices, and some accessing methods of IO devices. As far as this unit is concerned, I will give you a brief idea of this unit before starting this unit 5th, that is input output devices. Being a IT or CS student, or I will not say the CS IT student, nowadays the information, the introduction, the knowledge of this basic information of this computer system are being given in the very basic standard, like from the start, you will say from the third standard or the fourth standard in the schooling as well. The topics, the devices, the information which we are covering in this unit 5th, I feel if you have taken the some subject into the plus 2, 10th, 11th classes, you have learned all the devices. You are very much aware with the name mouse. You are aware with the keyboard. You might be aware with the laser printer how it works. So as far as the unit 5th is concerned, this is a repetition. This is a revision of your contents, your knowledge which you are already having in your mind. But you will be glad to know that from this unit as well. So if I will say the unit 5th is there, if a 100-mark paper is there, then out of 100, 20 marks will come from the unit 5th. As far as your scoring, as far as your marks, internal or external, you can gain from, you can score maximum marks from this unit, because this is the easiest or the simplest unit which you can learn from a single go. So I feel you will understand the topics very easily. But again, overconfidence always give the setback. So don't come into the overconfidence, and just take a single ride, single go through of this unit completely from some book. After learning or listening my videos, you have to go, you have to follow some books. Let's start unit 5th, lecture 1. Here, peripheral devices, again known as peripheral, or you can say simply you can say peripheral, but peripheral is meaning is that something which assists you. Whenever peripheral can be of the system, peripheral can be of your car, accessories. Same way, the device which assists, which helps some bigger devices, bigger unit to work in, that is called as a peripheral. Peripheral can be of a system, peripheral can be a computer peripheral, it can be a peripheral for another device as well. So again, we can say it's peripheral, it can be called as computer peripheral, it can be called as input-output devices, or any of various devices including sensor, printer. These all are called as the peripheral devices. Such devices make up peripherals equipment of the modern digital system. As far as this is the simple idea, simple pictures of your mouse, your keyboard, your laser printer as well. You might have heard, I feel from the day you have started learning computer engineering, computer science, you have seen the optical mouse. But before optical mouse, there was a mouse which was called as mechanical mouse. In that particular mechanical mouse, a ball was there, and the rollers, the x-axis or y-axis rollers were there. So they can move, they can judge, they can note, they can record the movement of vertical or horizontal. You can see, I will show you this feature, spotlight feature. You will see this is the vertical and this is the horizontal, which is recording. Here is the ball, this one is the ball. When you will move this mouse upside or downside, in the left, right, or up or down on your mouse pad, this ball will move. By moving this wall, the attached this particular you will see this is the ring. Along with this, it will move, and this shaft, along with this shaft, this ring will move, and along with this shaft, this ring will move. So by moving this, here was a light and a photosensitive sensor was there, which was sensing the light over here, and movement, the round movement of this ball was noting. And on the basis of this left movement, right movement, or vertical or horizontal movement, the movement of the mouse, the movement of the cursor was noted. But nowadays the optical mouse has been replaced. This optical mouse has replaced this mechanical mouse, and we are working with this complete optically sensed mouses. So this is the complete information of how the mouse is working, how the optical mouse, how the mechanical mouse is there. You can see a multimedia keyboard over here. This is the laser printer. This complete information how a laser printer work has been given. You can see from the point 1, 2, 3, 4, 5, 6, 7. The complete working of the laser printer has been given. You will see here residual toner removed from drum by scraping or by passing under a discharge and erasing the lamp. Uniform high voltage, the very interesting, very, if you are aware, you are fond of the physics, you will see it's a very interesting phenomena principle used over here. The charge has been, the toner has been sensed with some high negative charge. Again the laser beam, you will see these laser beams are giving only that particular area which is to be printed, like the figure of A, figure of B, or some any other figure, hard figure. Onto that particular area it is giving the positive charge, means the this particular negative charge, uniform high voltage negative charge applied to the drum will be make to the positive by these laser beam, where you have to print something, where you have to print the picture, the area onto which you have to print onto the paper as being positive charge. And by this way you can complete laser beam selectively discharge the image area onto the rotating drum, reversing the strong negative charge to the weak positive charge. So here we are charging the toner with the negative. This laser beam is discharging that particular to the positive. Which area? The area which is to be printed. Like you have to print A, B, C, D, or H, I, J, whatever the figure, whatever the character, whatever the word you want to print, that particular area will be discharged from negative to positive by these laser beams, and that complete printing will be done over to the paper. So this is the complete working of laser printer. By this way you can understand how a peripheral, how a you can say input device or a output device work. You have seen this input device, you have seen over here again input device, multimedia keyboard. This one is the output, that is laser printer. As far as this information is concerned, you will see the how the peripheral devices are work and how many types of peripheral devices are there. These are two or three types. One is you can say human readable, you can say machine readable, you can say communication readable, or you can say the devices which helps in communication. What are the human readable? Which are suitable for communicating with computer user, like you can say VDT, video display terminals, like, or the printers, you can say the monitors or the printers. Machine readable, suitable for communicating with equipment. Example, magnetic disk, type system, center, actuator. What are the communication devices? Communication peripheral, the devices which helps in communicating are called as communicating suitable devices. Example, human readable devices such as terminals, machine readable devices, or even another computer. So these are the different type of peripheral, or simply you can say the devices which help. Simply we can divide human readable. We can another second part is machine readable, and third one is communication suitable for communication. As far as the different another working of these type of devices concerned, it is related to the control logic. it is related to the buffer, it is related to the transducer. But a control logic is, it associated with the device control or the different type of control operations, device operations in their directions, their IO module are being controlled by the control logic. As far as the transducer is concerned, it converts the data from electrical to the other form of energy during output form of the electrical during input. A buffer, what is the requirement of buffer, is associated with the transducer to temporarily hold data being transferred between the IO module and the external environment. What is the need of buffer? The need of buffer is that the speed of the input output devices as well as the device, simply you can say the processor, is not matching. There is a mismatch between the speed of the device in a output device or input device, or simply you can say the peripheral, and the speed of the processor is very mismatching. So to make that, we required another device that is called as buffer or synchronized devices, which temporarily hold the data which is being transferred or which is to be read upon. So as far as the devices are concerned, there are two main type of devices are there: input device, output device. From the list, you can understand why we are saying these as input device, why we are saying these as the output device. I feel it will be very easy to understand all the devices, input devices, the keyboard, optical input devices, card reader, paper reader, magnetic input devices, screen input devices, analog input devices, and another side you can see the output devices. You have card puncher, paper, tape puncher, CRT, printer, impact. These are the types of printers like impact printer, inkjet, laser, dot matrix, plotter, analog, voice. Again, if we are sending any information through the voice, then it will be called as the output devices. If we are receiving, then it will be called as the input device. As far as input and output devices is concerned, how they work, how they associate with the IO module, you can see with this diagram. You will find IO module interface to the system bus controls. One or more peripheral devices can be connected with IO module. What is the need of IO module? Why one does not connect peripheral directly to the system bus? The reason are as follows. I told you, you simply can have a question in your mind, why we are a requirement, why there is a requirement of IO module, why we are not connecting our device. I will show you with this spotlight feature. You can ask me, these are the some input devices, or these are the some peripheral which are being connected through IO module to the system bus. You can ask why we are not connected these peripheral devices to the system bus directly. You can have a question in your mind. The answer is here. There are a wide variety of peripherals with various methods of operations. Many type of peripherals are there. Some are reading, some are writing, some are having a high speed, some are working with the byte. You can say they are reading the information on the byte, but this particular is the buses are working in the form of word. The size, the unit of data they are reading are in the word, whereas the devices, input device or output device, are working with the byte format. So again, the data transfer rate of the peripheral is often much lower than of memory or the processor. I told you there is a mismatch between the speed of the IO devices and the speed of system bus or the processor or the memory. The data transfer rate of some peripheral is faster than that of memory or the processor. Peripheral often use different data format. Like I told you, these peripherals are using byte word length than the computer to which they are attached. I told you the peripherals are using the word format, data format into the byte, whereas processor or data bus are using as the word. As far as this IO module function is concerned, you can see this is the complete information how a IO module works. The major functions of requirement for an IO module fall into the following categories. The functions are control and timing. The function are processor and communication, device communication, data buffering, error detection and correction. So these are the 4 to 5 modules into which IO module functions. How a IO module works. It works upon the 4 or 5 modules like control and timing, like the processor communication, device communication, data buffering, error detection. So you will see the complete working of this through the next figure. Here you will find the working of IO interface. The working of this IO interface can be seen via this information. You will find this is the complete working of IO device to the CPU. There are multiple modules which are coming in between the CPU and the IO devices. You will find out the working and the interface. You will find out how this input output interface to the CPU has been done. I will start with this truth table only. First of all, you have to understand these five words. This is the CS, that is chip select. This is RS1, this is called as register select 1. This is RS0, that is called as register select 0. So from these three input, and the selection of the register which has been selected by selecting these inputs for the truth table, you can understand how the IO interface is taken place from IO device to the CPU. This CS is chip select. If it is being set to the 0, means the device is disabled. CS means disable or enable. If it is disabled, then it is set to the 0, and non means no operation will be performed. That is, data bus is on high impedance. If we are making this chip select enable, or we can say we are selecting this CS chip select as 1, means high or enable, then the complete operation will be performed. Whether this register select 1 is set to 00, then this port A register will be enabled. If this register select 1 is 0, register select 0 is 1, then port B register, this port B register will be initiated. Now, if keeping this CS on enable position, that is high position, we are working. Here, if it is high and this is low, then control register, this one. If both are 1, both are on the high, then status register will be enabled. So by this way, we are working with IO device to the internal bus, and thereafter bus buffer, and thereafter with the help of bidirectional data bus to the CPU. So you will see another information from over here, programmable interface. Information in each of the port can be assigned a meaning depending on the mode of the operation of the IO devices. Port A, this port A, that is data. Port B is command, and port C is status. So CPU initialization loads each port of the transferring a byte of the control register, allows CPU can define the mode of operation of each of the port. So this complete working from IO device to the CPU through this IO interface can be understood by this diagram. Only you have to understand this truth table. Otherwise, the complete information can be learned, can be seen from the figures over here, produced over here, and the complete information is given with the programmable interface information over here. I feel you have understand how the IO interface works. As well as accessing the IO devices, the information has been given. How we can access IO devices? This complete information is over here. Accessing IO devices. This is the processor. It is memory over here. The processor asks something to read or write into the memory. It takes the help of the bus. This is the IO device 1, IO device N, 1, 2, 3, 4, 5, 6, 7, N. So multiple IO devices may be connected to the processor and memory via a bus. This is called as the system bus. Bus consists of 3 sets of lines to carry address, data, and the control signal. Every time if you are calling about some interface, you are discussing about some interface between two devices, then minimum 3 types of buses are being required. One is called as the data bus, address bus, and the control bus. Each IO device is assigned a unique address. To access an IO device, the processor places the address on the address lines. The device organizes the address and respond to the control signals. So by this way, accessing of IO devices can be confirmed, can be done over here. This is the processor and this is the memory. Over here you can understand how they are connecting to the IO devices, how they are taking, how they are serving the information of reading something from the memory or writing something into the memory on the request of the IO devices, that is input output devices. So by this way, this processor serves the request of IO devices with the help of bus. These three minimum buses are data bus, control bus, and address bus. And by this way, you can say how these are the connecting, how these are accessing to each other. So accessing IO devices continued again. IO device and the memory may share the same address. There are two type of policies. There are two type of principle. The principle is that memory and this particular IO devices can share the same address space, and they can have the different address space. There can be two type of principles. There can be two type of the phenomena. Features like IO device and the memory can share the same address space, whereas they can have the different memory address space. So memory mapped IO, any machine where they share the same address space, this type of situation is called as memory mapped IO. Any machine instruction that can access memory can be used to transfer data to or from an IO devices. Simple software is being required, where IO device and memory may have different address space. Here, special instructions to transfer data to and from IO devices. IO devices may have to deal with the fewer address lines. IO address lines need not be physically separate from memory address lines. In fact, address lines may be shared between IO devices and memory with a control signal to indicate whether it is memory address or an IO address. So these are the two types. They can share the same address space or they may not share the same address space. So difference is very much clear over here. You can understand how these input output devices are accessing to the system. As far as this complete information which we have discussed in the past can be learned from this diagram over here. These are the three lines: address lines, data line, control lines, means the buses: address bus, data bus, control bus. Over here, this is the address decoder, this is the control circuit, data and status register, and these are input output devices. How these work? The information is over here. IO device is connected to the bus using an IO interface. This is IO interface. These are the IO input. These are the devices, IO devices. These are connected with the bus through IO interface. IO device is connected to the bus using IO interface circuit, which has address decoder, control circuit, and data and state register. Address decoder decodes the address place on the address lines, thus enabling the device to recognize its address. Data register, this particular data register over here holds the data being transferred to or from the processor. Status register holds the information necessary for the operation of the IO device. Data and status registers are connected to the data lines and have unique addresses. And this IO interface circuit controls coordinate IO transfer. This complete IO interface circuit coordinate the IO transfers, means how you are transferring, you are reading upon or writing on to the memory, or some information has been accessed through the processor, are being controlled by this IO interface. So accessing IO device again, in continuation to the last slide, recall that the rate of transfer to the rate of transfer to and from IO devices is slower. As I told you, the rate of data transfer from this particular IO to the memory, or IO to the processor, or processor to the memory, or processor to the this output devices or input devices is differs, means there is a large gap, there is a difference between, there is a mismatch between the speed of the IO devices and the processor or the system bus. So these type of devices are slower than the speed of the processor. This creates the need of mechanism to synchronize data transfer between them. So this required a control of the IO, or simply you can say the program controlled IO. Processor repeatedly monitor a status flag to achieve the necessary synchronization. This is called as processor pool or IO devices. Two other mechanisms used for synchronizing data transfer between the processor and memory are interrupt and direct memory access. There are the two different ways by which you can synchronize data transfer between the processor and memory are called as, one is called as interrupt, another is called as direct memory access. So by these two ways, you can synchronize the data transfer between the processor and the memory. In the next lecture, we will understand about the interrupts. There are many types of interrupt. Thereafter, we will learn about the direct memory access. So till now, I will advise you to learn to go through with the particularly this lecture 1, and thereafter you have to start learning from the books. I again repeating this this unit 5th is will be very easy for you to learn, to understand. The only again repeating, my advice is that don't be overconfident, and one go reading or listening the video is very much required. Again, I from my side, I thank you all for listening.